Hello, everybody, and welcome to our think tank number 5, Latin American Cities Implementation. It's great to have you all here today. And this morning, we're going to be talking about a very interesting subject, which is how we are going to implement urban air mobility in our cities. And it's a very interesting thing when we talk about what we're doing and what we're trying to develop, because we always tend to go towards the aeronautics side and talk about the air vehicles and the airspace integration and so on. But it turns out that urban air mobility actually tries to solve city problems. It's about the urban scenario, and it's about the type of situations that we're trying to approach in our cities and the customer base in our cities. And actually, when we talk about urban air mobility and refer to all the vertiports and the air routes linking vertiports, we refer to those as infrastructure. That's actually a new type of infrastructure that does not require any physical building. It's actually virtual. And as such, we treat those problems in the urban scenario in a radically new way. And in that, I want to get started to talk about what we expect the impacts of urban air mobility to be when we implement these systems in our cities. So I want to introduce a very diverse panel that we have today to talk about the impacts of urban air mobility in our cities. First, we have James Sherman. He's a director of strategic development at the Vertical Flight Society, electrical engineer with over 25 years of experience in business development, project management, and engineering, developing technology for aerospace, automotive, military, and consumer products. Jim is responsible for supporting the development of the electric VTOL revolution. Luis Alonso from MIT. He is a research scientist at the City Science Group at MIT, has a PhD in architecture, and oversees the integration of the group's diverse research topics: energy consumption, city simulation, urban mobility, innovation district, and smart housing in City Science Network of Collaborative Cities, to provide comprehensive solutions for urban and country challenges in order to transform cities into more diverse and vibrant human-scale ecosystems. Jared Esselman, he's a U.S. Air Force veteran, a Harvard graduate, and manages the statewide aviation system in Utah. His company, Airio Transportation Solutions, is helping government and corporate transportation agencies with corridor and land use planning. Simon Briceno, Dr. Simon Briceno is head of advanced air mobility at Jaunt Air Mobility and is responsible for Jaunt's operational initiatives and business development in the advanced air mobility ecosystem. Prior to joining Jaunt, he spent 15 years as a research faculty at Georgia Tech, leading research in transformative aviation. And joining us as well is David Russell. He's CTO of Airio, and he's a research engineer with 40 years experience in hardware, software, and control system theory. He has published a number of papers, including this year's AUVSI, and has 8 patents granted, over 20 recently filed in the areas of unmanned aerial vehicles, control systems, and applications. 7 companies, including Airio, have been founded on his research. And with us as well is Mario Cruz, head of data science in Varon vehicles. So thank you all, guys. And today we want to get started by talking about the overall reason why we are implementing urban air mobility in the first place. What are we trying to achieve with this? And as I was saying at the beginning, we have to take an urban perspective, a city point of view to answer that question. What type of problems are we trying to tackle? What are the impacts that we expect to see, be them positive or be them negative in our cities? So with that, let's get started and with an introduction to a subject and a term that we have coined in Varon vehicles, which is an urban geodesic. That's something that we have defined as the shortest path between 2 vertiports in the urban air mobility scenario. And of course, when we design these airspace volumes between vertiports, we have to take into account no-fly zones, weather conditions, we have to take into account topography, and other known variables of the low altitude airspace over a city. to design these lanes. And that's a tool. The urban geodesic is a tool that helps us organize traffic in the air as we design urban air mobility for the city. So why don't we get started with going backwards again, as we did in the last think tank. Let's start with David, because in Airio, they're designing these systems for route generation. So it has everything to do with urban geodesics, and we'll take it from there. So David, over to you. You have to unmute.
There we go. Thank you, everyone. So in terms of the urban geodesic, this is a fairly well understood problem. It can be handled in two different ways. When we're dealing with one vehicle and its particular flight path, we generally build a three-dimensional model of the area through where it's going to pass, and then we define that particular variable. In this case, we're defining a more permanent structure, so we can take more time to do that. So there are optimization routines that can be brought to bear, and then there are basically auto-routing types of routines. But they're all based on what's called a cost function. And that's where you define the variables that are going to impact what you call whether it's good or whether it's bad. So in terms of good, you want to say, okay, I'm going to minimize distance, but at the cost of how many times do I have to change directions or change altitudes? Do I want to avoid flying over schools? Do I want to enhance flying over railroads or cars or other items? So by creating this entire list of variables that we can measure, say on a 10-meter grid throughout the area, we can then do either an optimization sweep or a simple metric search, which is sort of like saying, do you want the best solution, or are you good with getting one of maybe 100 good solutions as opposed to the best solutions? So that's how basically it's fairly easy to solve this problem, especially since you're only looking for one real track with a lot of definitions. And that's basically what we do.
Perfect. So the important message there is that the traffic of air vehicles in urban air mobility is going to be organized. It's going to be organized in defined parts of the airspace, which we call airspace volumes or lanes, virtual lanes. So Simon, what's your opinion on these points? Going backwards, as I said, over to you.
Yeah, thanks. And I think, and David, mentioned all the key inputs to being able to design these routes. So it's definitely very critical from a sort of an operator or aircraft standpoint. Some of those inputs will include the flight profile that is certainly specific in some ways to the aircraft from a performance standpoint. The approach and departure procedures, all those details have to be defined. As you fly lower to the ground, as you know, there's going to be certainly a really important need to understand all the topography, the obstacles on the ground. And I know there's quite a lot of effort in the community leveraging GIS, Geographic Information System, to be able to model those. Another part of it too is not just to have a good understanding of what to avoid on the ground, but to ensure that over time, your model is updated. And we know that quite well with helicopter operations and power lines. It's a big concern as helicopters fly low to the ground today. New towers, power lines, all of those are obviously major critical elements. And so as we design these geodesics, in cities that are constantly growing, and where, you know, people are building new buildings or other potential obstacles. You know, those are important to take into account, not just from the beginning, but you know, over the operating life cycle as well.
Yeah, and hopefully the urban geodesics turn out to be as close to a straight line as possible. But the reality of urban scenarios mean that the urban geodesics are going to end up being different to that. And by all means, before going over to Jared, I'm going to remind our attendees that you guys can submit your questions at any time. Just use the questions and answers button on the bottom of your screen. And we'll have a slot at the end of the think tank to try and answer as many questions as possible between all panelists. So over to you, Jared, and you're leading an ecosystem as well in Utah. And as such, I think it's a very relevant question to ask you what your point of view is in what the impacts that we're expecting for urban air mobility to have in actual cities.
Sorry, thanks, Felipe. I've got a fire alarm going off behind me, apparently. So it's a great question. You know, we're looking at our ecosystem in Utah as not just a connection of vertiports, but intermodal units, right? So we already talk, and city planners, matter of fact, I'm glad Luis is on here. Luis, we should connect afterwards. Our city planners talk in intermodal already. Often we find that planners, whether they be urban or regional, you know, when you mention aviation, they're like, well, there's aviation guys for that. We leave that alone. So we find that we have to talk in their language, and connecting intermodal points and figuring where those intermodal, whether it be a train station that connects to a bus stop, or a parking lot, or a freight transition from rail to truck. You know, we have to find those intermodal points, and that's what we're trying to connect. I love the idea of the geodesics. We actually took from a political stance. Now I understand, you know, in South America, the politics is a little bit different, and I love your concept of it, of the geodesics, of the lower flying. For Utah, we took our virtual lanes and we said, what's politically palatable? How do we connect these intermodal points? And what's, you know, feasible, right? You want it to be a straight line, but what's accepted? What's politically accepted by the people? And we found that taking the roadmap and just elevating it 400, 600, and 800 feet, they already accept transportation along those routes. They already accept that as a noise conduit. They already accept that as a pollution conduit. They already accept it as a transportation conduit. Just elevate that transportation conduit. But one of the things we know has to evolve, and I loved Simon's point on this, is as buildings grow, as cities grow, we have to think of, for FAA purposes, the Part 77 surfaces of those intermodal landing takeoff operation points, right? So we don't want to, as an ecosystem, we don't want to prevent new buildings coming in, new towers coming in, but we also want to design approach and departure paths into those geodesics, into those corridors, to allow for that new construction to continue and still operate a seamless urban air mobility environment.
Right, I think you bring up a very important point, and it's the fact that as we design these urban geodesics to link those mobility hubs, be them vertiports and the rest of in the intermodal transportation in the city, there are criteria, as David was saying, and part of that criteria, to add onto his thought, it's the emergency landing zones. We need to plan around those as well to allow for emergency situations to be managed appropriately, and eVTOLs to land as soon as possible along the way. So with that, over to you, Luis.
Well, I think, this is very exciting, and I really like the point of view of Jared here. This idea of, you know, like this intermodal connection between different mobility mode choice So I think flying cars are gonna came as another option for mobility. And here, as a urban planner, we always think on different what-if scenarios. And we have the same issue with autonomous vehicles, for instance. For sure, if you look into 100 years in the future, maybe all of the vehicles are going to be autonomous. It doesn't matter if they fly or they are running in roads, but probably that's going to happen. But in the midterm, we are going to have kind of like a hybrid kind of a scenario. And I think for this challenge of flying cars is going to be something similar, where we are going to have to coexist, like the current situation plus the new situation of some kind of vehicles that are going to be flying. But I like to look also into the other extreme scenario where maybe in less than 100 years, like maybe 50, cars are going to be flying, and how that is going to shape the city. So we are going to have what architects usually talk about vertical cities, and this kind of multimodal kind of infrastructure is going to be needed in a way that is also vertical, because actually when you shift from the bus to the T station, you have to move in like in the vertical direction, and that's already like a challenge in some cities. So imagine like going, I don't know, like in a tower, because you have to take a transportation, so that tower probably needs to be special. And also I am very interested on privacy issues. So depending on how is the height of the flight, I mean, like maybe they are just flying more or less at the same level of buildings, and then you need to have some kind of privacy. I know that if we look into the first scenario, like just some, let's say, kind of like a helicopter premium kind of a scenario where you have flying cars from with very clear paths, etc. I think that's, as Jared was saying, that's already like kind of solved because we can kind of use the legislation. But if you look into the more futuristic scenario, I think that's opening a very exciting door where probably depending on if you are moving people, probably you are going to be flying in one level. If you are moving goods, maybe in a different level. So privacy is not being an issue. Probably even like in the movies, the commercials are going to be like, I mean, like you're going to have a tower with probably some neon kind of commercial in the higher level. So as an urban planner, I think just the idea of thinking on how these vertical cities are going to be is amazing. How the street is going to be if you remove all the cars. So are we going to go back to history when cities, they used to be more human scale and we remove the cars so the street is for humans? Or are we going to have different levels in the city where we are going to have walkable streets like in different levels? I don't know. For me, it's very exciting, and I think this is opening like a huge and long conversation. But I think for now, I think I feel very comfortable having people like David and Jared and Simon thinking on this geodesic points of view, where you have this very clear path and you have points that they are specific for commute. But I will also open a little bit the door to the more futuristic point of view.
I think that what's really apparent here is and evident is that urban air mobility, it's about mobility, it's about the city, it's not about aviation. The aviation part of it is just a tool for us to achieve a mission in solving city problems. And with that, of course, we are expecting there to be impacts in the architecture of cities, and the planning and the development and in this restructuring of our cities in every aspect around mobility and the new modes of transportation. So with that, over to you, Jim.
Wow, I think we've covered quite a bit of it. I have a couple of points. First off, defining specific routes is a great idea. That also helps you take some metrics along the way and see how we're doing with the early introductions. I think we also have to worry about some things like the Jaunt air mobility vehicle will travel at with a certain envelope and a certain speed, and the Joby one that comes along right alongside of it might be traveling a little bit faster. So we need to monitor how those routes are defined. I like the idea that defining them along predefined transportation networks is a good thing. We have a lot of community and issues that we have to deal with, and noise is one of them. So if we start off with areas where there's already a fair amount of ambient noise, we kind of fall into the background. So I think that's going to be key for getting some public acceptance. That also helps reduce some of the risks on the ground too. We do know that as much as we want to put 10 to the -9 safety on the vehicles themselves, there are some additional risks, and there will be the likelihood of, we're not looking forward to fatalities, but there will be some crashes to some of these vehicles, and putting those vehicle routes over areas where we limit the risk to the ground, I think is going to be a very key aspect of this. And also how we manage those routes from other unintended consequences, like we have a significant number of drones out there flying. How do we keep them out of our space, or at least avoid them along the way? So I think there's lots of good things that we need to talk about, and there's some things that I'm not trying to be the naysayer by any stretch, because that would really default what we're trying to do here. But there's a lot of risks that need to be addressed, and I think starting with the defined routes is a very good way to do that.
Absolutely. One thing when we address all these points in the future mobility and urban air mobility, one thing is to think about what it will be in the future. A very different thing is to address how we're going to get to that point. And indeed, this is going to be a gradual development and a gradual implementation. We are seeing very, very much initial phases being planned right now for the following years. We, at least in Varon vehicles, we don't think that we're going to be transporting people anytime soon. Apparently, we're going to be transporting packages before we transport people. And there's going to be a prior phase before transporting any packages, in which we need to test the systems. We need to integrate all the different systems. Urban mobility is going to be a system of systems: air vehicles, airspace integration, vertiports, ground systems, energy subsystems, etc. So the implementation of all these is going to be gradual. So having very early stage airspace integration architectures that allow for very safe, very controlled, and very confined first implementations is really, really crucial and very important. And that's something where Latin American countries actually do offer a very high value, because this is a place in the world where we find very low requirements for urban mobility, shorter distances, we can fly at lower altitudes, and so on. So I want to turn into a different aspect of the city and the urban scenario, which is the people, the people we intend to serve. Eventually, when we reach that point of transporting people, well, that's the customer base. That's the people we're going to serve. Let's talk about them. Let's talk about our market and the demand, and the actual street person, the regular Joe, who is going to be asked or offered to board one of these aircraft and fly, where before they used to have a bus or a train or an automobile. Now we're going to be offering an airborne system with a radically new type of air vehicles. That poses two things, two subjects that I'd like you guys to touch on. One is the safety perception. One thing is to talk about safety, that's certification, how safe the systems really are themselves. But a totally different thing is safety perception. And a different aspect that I'd like to throw onto the table is the fear barrier. Are we expecting people to be scared of flying in these vehicles? Are we going to be having people or offering a service to people who have never flown in their lives? How do we address that fear barrier that we know we need to break with things like a seamless experience throughout the vertiports, with the comfort during the flights, etc.? So who wants to jump in onto those? You have to unmute, please, if you want to jump in. David, over to you.
Sorry, I keep forgetting. Is that one on?
Yes.
So now it should be on. Okay, sorry. I think the fact that you're going gradual is very important to the entire process. When you look at it from the two aspects of fear and perception of safety, you have to go back to very human fundamentals. Fear is based on something you don't understand. And perception of safety is simply a level of comfort with what you are used to. So in terms of, you need to deal with visibility. You start off, as you said, you're not doing anything but flying around. That helps people just to understand that these things are in the air, and over time they get used to them, and that brings in a certain level of comfort. Once you get to there, then the next thing you look for is to make it as to relate these functions to something that they understand already. So for instance, the first cruise control in cars was introduced in 1958. And by the time you got into the 70s, there'd been over 40 different evolutions of those kind of products. And by now, we have over 32, I believe, different kinds of driver assist. So your language becomes something as well that they understand. So this isn't an autonomous vehicle. This is a vehicle that has a whole lot of driver assist up to the point where you don't need the driver anymore. Basically by doing that, you get into a point where as you move from one of these points to another, so you start with an actual driver. They're used to that. It's a taxi. Okay, so it's going in the air. I've got a little bit of something to get used to, but that's a small threshold. And so you keep providing small thresholds until you add cruise control. So now we have very accurate timing and spacing within the lanes. Then we add lane assist, to where now the driver is not really doing much except explaining all of these things to the people that are in the car or in the vehicle. And eventually you get to the point where he says, "Cool, you're all set to go," and he presses the start button and closes the door. I come from also a theme park background in the Orlando area, and getting people to get on things that make them scared is kind of what it's all about down there.
Cool. Okay. Anybody? Simon?
Yeah, I just wanted to add to what David's. This is a really critical aspect of our deployment of this new type of aircraft, new technology, new mode of transportation. It's really the public acceptance, and one key component to that is certainly the perceived safety versus real safety, which is often a conflict, as David pointed out, between facts and fears. People will make their own safety judgment based on what they know about aviation safety, which can be based on their own flying experiences or what they see and hear in the media. There's a lot of information that is out there that may or may not be accurate. And so, even if we tell them that the equivalent level of safety will be, in terms of, as Jim pointed out, the system failures per number of flight hours, let's say that 10 to the -9, and with the highest development assurance levels as we're building these aircraft that are equivalent to current airline transports, that doesn't compute to the average person. You can tell them that, but you really need to show them that, you're going through the rigor as it pertains for the aircraft development that is equivalent to airline transport. Let's say people associate safety with flying large aircraft, large airline jets. So from our standpoint, at least at Jaunt, one component to helping that is certainly from a visual standpoint. Our aircraft resembles both a conventional helicopter and a conventional airplane, and we believe that does bring some level of comfort to operators and passengers. And at the end of the day, though, the majority of people will tend to associate a lower level of risk with something they're familiar with. And that familiarity, as you pointed out, Felipe, will have to begin with that crawl phase where you help them visualize with their own eyes. No simulations, no words. You have to show them that how this works, what are some of the contingencies that are put in place. All of these aspects have to be demonstrated over time, and let people understand and accept how this is going to function, and then build trust into that system. And one last point I'll make too, that safety is not only associated with the aircraft, but also clearly with the ecosystem, the air traffic management system, and the ability for aircraft to detect and avoid or self-separate, or whatever type of architecture for the air traffic management will be in place. That's going to be also very critical to ensure the safety of the operations in a potentially very congested airspace.
Great.
Can I, super quick? I think we are not facing something new. I mean, like in transportation, we always have, I mean, every time that you bring a new animal into mobility, you always have the same problem. I mean, like with the train, people were thinking like, if we go faster than 60 kilometers per hour, we are gonna just vanish or explode, or so that was the train. With the car, same thing, and of course with the planes, and every time we manage to find out like this balance, as I think Simon and David, they were talking about, like this balance of showing that this is safe, but at the same time you have a win-win situation, because you try this new mobility mode choice, and then you have something very good happening to you. And sometimes it was just a cool approach, because we are humans. And I think David was making a very good point, like this amusement approach to safety and security. So cars, I think they grow up very big in France at the beginning, because it was something almost wild. And you was risking your life by driving a car in France, because at that time, nothing was there. And even also the same happened with the small planes. There are movies about that, about how people were risking actually in Latin America their lives in order to bring the mail from one country to another, going through the mountains when planes were, like just 20 years old. So I think as humans, we are facing this all the time. There are several ways. I think we already have talked about show that is safe and give all the transparency, etc. At the same time, build trust, but at the same time, you need to have like the cool approach, like this is also something that humans are going to be excited about doing. And I think that is related to the American dream, for instance. So the car was successful because Ford and Rockefeller, they built the American dream. No. The train, yeah, it's amazing, but that's not what you want. You want to have your individual way of moving from the city to the house, and the house is in the countryside. And then people were buying that idea. So I think that in the top of this, we need to have like a dream or something like that, something exciting that makes humans to buy this idea, and the same thing is happening with autonomy. So if we don't make humans being interested in autonomy, it's going to be a lot of, pushback, and legislation is not going to happen because people are, and I think that is what is happening with autonomy. We are trying to make it sexy and interesting for humans, but the truth is that a lot of people like to drive their own car, and they like to, the sound of the car, the excitement of just getting under control of a machine. So I don't know exactly a solution, but I think that's one of the points that when we talk about mobility, you have different types of reasons why people are using one transportation mode, and excitement and experience is one of them. And I think flying cars has a lot of that. So maybe it's safer to take a plane, or maybe it's the same safe, or to take a train, but here you have a unique experience that you can have.
That's clearly one of the reasons why urban mobility is so exciting. It's shaping the future of our cities and our ways of life in many ways, and the new types of mobility, by all means. Before we carry on, I want to remind our attendees that you guys are able to submit your questions through the questions and answers button on the bottom of your screen, and we'll try to answer as many of those as possible among all panelists. We're already getting a few questions in, so keep them coming. Let me throw out a couple of other subjects that we want to cover in this very short panel, and it's two things. As we develop these urban geodesics, that concept allows us to organize the traffic of air vehicles in urban air mobility over the cities. But the question arises there, what's the traffic going to be in the city skies? Are we expecting to see high levels of traffic in the air? Are we going to move the traffic from the ground up into the air? Or is it going to be a different way? Is it going to be a less congested airspace at the same time as we serve a larger number of people? What do we see around air vehicle density expectation? And the other question I want to throw out to you guys as well is the energy source. One of the biggest ways in which urban mobility is going to impact our cities is in the demand for electric energy. Many of us tend to go towards electric air vehicles, even though at earlier stages, the air vehicles may be fuel-based or use some other types of strategies like hybrid electric type of powertrains. But in the end, we do tend to go towards fully electric vehicles. And the biggest question we have there is, where is this energy going to come from? And what that's going to impact in the environment. So those 2 points to you guys. Over to Jared.
Yeah, I'd love to take that one. I will say on the fear question, one of the things we had to respond to was not fear of getting in the vehicle, but fear of being on the ground and it falling on your head, right? So I don't want to be at home enjoying lunch and then all of a sudden something comes crashing through the roof. That was one of the fears we had to get over, which putting them over the already accepted transportation corridors helped alleviate that perception of fear. As far as the power goes, the energy goes, that's a question we've been working with. Rocky Mountain Power is our major power provider here. They're looking at the intermodal functions, these electric vehicles. How long do they charge? Is it a fast charge? Is it a slow charge? What kind, for one vehicle, they say they can provide the number of kilowatts already in the system, in the grid. But as we get to more and more vehicles, which comes to your question on air density, they know they can't provide that power. I know everybody loves solar and wind, but solar doesn't cut it. It would take, we'd have to cover half the state in solar panels to provide the amount of energy it would require. Putting up windmills is kind of intuitively contradictive to urban air mobility, and then throwing up a windmill, this doesn't go together. So we're definitely going to have to look in other places and increase our power production. For air density, we have developed a simulator that allowed us to say how many vehicles, how many package delivery drones, how many aerial taxis can we fit into just the geographic space of the city of Salt Lake. And what we found is if we use the correct timing, if we set a speed limit, if we design the lanes properly, and if you have an unlimited number of ground points of intermodal vertiports, so to speak, we can fit about 3,000 vehicles in just the 15 square miles of Salt Lake City in that airspace, and before we reach a bottleneck. However, the thing we learned is the number of vehicles in the air isn't limited by the airspace. It's limited by the area on the ground where they can land. That's the bottleneck. That's the point of truth, is if you have an event, an emergency, where you need to get those vehicles on the ground, you can only fit 100 vehicles on the ground, but you have 2,000 vehicles in the air. That doesn't work. So we found that even on timing, right? Even if you're talking if you're talking about the timing of how long it takes to descend, to unload passengers, load passengers, and then ascend and get back into the corridor, we simulate those. It's not so different than a traffic simulator that any DOT uses, right? Measuring traffic jams. But we use that simulator to measure If we increase those times, decrease those times, how does it affect the number of vehicles you can put in the air? One of the other things we use it for is, especially for package delivery drones, is we show people these are small. I mean, you know, people are worried about, I literally had somebody tell me, well, they're going to blot out the sun. They're going to be everywhere. You're going to see them. Well, at 600 feet, if you can find a package delivery drone, you have better eyes than I do, far better eyes than I do. And at 800 feet, if you can find an aerial taxi, I'm impressed. They, you know, look like in the sky. And at 800 feet, you can hardly see them. So, you know, as we talk about air density, it's not like there's going to be just little black dots everywhere we look up. It's going to be difficult to see. And it's a big sky. Like, we limited ourselves to 400, 600, 800 feet. That's where we put our corridors. But that's not the limit. We can continue to go up. And there's a lot of vertical space out there.
Right. Who wants to comment on this? David?
If I might, I totally agree with what he's saying, especially the part about it's a big sky. We do the same kind of simulations, but we don't have corridors. The system that we've been working on creates 4-dimensional flight paths to where, you know, basically they're at, let's say, 10-meter accuracy, but we can, with part of our system, we have a regulator that can go into the autopilot that guarantees basically that the vehicle stays on position, on velocity, and on time for the entire flight path. With that, we can deconflict them before they take off. So we run simulations where we've flown over 300 vehicles simultaneously through 1 square kilometer of downtown San Francisco without even having to go into the 4th dimension to deconflict them. So there are a lot of things we can do. In the case of Latin America and the vertiports, where the rubber meets the road, if you will, is in the VIMAs. You know, for 1 or 2 VIMAs, you know, 2 lanes attached to the VIMAs, there are a lot of different solutions you can do there. But what happens is, in the simulations, you know, if I've got a very simplistic system, which we'll start with, you know, I can send up one, you know, I can send up, you've got 9 lanes and 3 levels. So I've got basically 27 slots that I can put a vehicle into. And if I do that, say 1 minute at a time, it really doesn't matter how long the path is between them. Once you start that process, you know, you're getting roughly 60 vehicles an hour. But as you add in more and more autonomy to where I can manage the speed and I can manage the actual flight, the actual takeoff and landing autonomously, then you can quickly jump up into 6,000 flights per hour instead of 60. And you know, that simply is because of the precision with which you can get in and out of those corridors and the VIMAs.
Yeah, before taking it to Simon, I just want to clarify that VIMA is what we've defined as vertiport intersection management area. It's the area around the vertiport. So it's that bottleneck that you guys are referring to. Simon?
Yeah, I'll make a quick point. I just wanted to, I think Jared and David are spot on the bottleneck. It's on the ground. And the best way to sort of think about this is just to draw the analogy with aviation today. Where do you have the delays? The delays don't exist when you're at 40,000 feet. The delays are at the airport or the terminal area. And that terminal area is where it gets congested. And that's just going to translate exactly to vertiports. You're going to have now potentially hundreds in a holding pattern. What if something goes wrong on the ground? You have to have the flexibility in the operations to account for, especially with the high tempo of operations, you have to be able to spill over into a different vertiport, you know. And so from a scaling standpoint, you know, we're not gonna start off with thousands of operations from day one. I think we all know this, right? and look at, I think we should learn a lot from today's aviation. The constraints that are capacity constraints that exist in terminal areas have a lot to do with air traffic management and the technologies and infrastructure that we're using. We're using, 60-year-old, we're still communicating. Humans are communicating. I'm a pilot, I fly for fun. I'm using just basic human words to communicate where I am at any given point in the terminal area. We have to change that, and we have to change the way we manage aircraft to make all of the high tempo operations that we're talking about. Otherwise, we're just not going to provide the safety of separation between aircraft, especially in low visibility IFR or IMC conditions. So anyway, I just wanted to agree with that. That's really critical, that it's going to be at the local ground level where you'll see that density issue.
Yes, if I could tack on to a little bit of that. So on the general mobility side, are we going to have thousands of planes flying in low altitude, blotting out the sun? No, I don't think that'll ever happen. There's a lot of talk about how these vehicles actually get integrated. The initial thought was it's going to fly around downtown, land on buildings, land on parking garages. I kind of see that that's probably not going to happen unless they're purpose built from the start. To retrofit a building to hold an airplane for landing is enormously expensive, and I don't think that changes from country to country or region to region. I think what we're going to find, though, is what urban air mobility provides is the ability for us to expand the lateral size of our cities, right? So those places that are on the outer edge or just outside the outer edge, now you have access to the city without having to get stuck in long lines or go find yourself a rapid transit system to get into the city. This is what that's going to do. This is going to allow for, like, the Washington, D.C. area, if it ever comes here, would be to allow those cities or small towns in like Martinsburg, West Virginia, beautiful place to be, really hard to get to D.C. from, right? It allows people from Richmond to commute into D.C. And those kinds of things. So I don't see this being an area where it's going to blot out the sun. As far as the energy source, that is a real issue. So fortunately, we're going to start out with 6 or 8 a day from a certain place, making up numbers obviously, but so you can start out with drawing it off from the grid. Most likely, you'll have to have some local storage. Over time, as you start to build up more and more, you're going to have different forms of propulsion. All right, so it still might be electric propulsion, but it might have to come from a fuel cell source or a hydrogen source, even if that's a combustion kind of hydrogen source. I think there's time, for us to figure those things out. But as the number of vehicles grows, it's really gonna put a strain on our system, especially at the same time as all the auto manufacturers are converting to electric as well. It's going to be a huge burden. And I don't believe we've put enough, can't say for certain, but I don't think we put enough time into thinking about how that's going to work with everything going electric in the near future.
Perfect. So yeah, I mean, before we go into questions, we have a few already that we want to throw out to the panel. It's clear that the density of air vehicles in the air is probably not going to be that high, that the logistics problem is going to happen at the vertiports. And designing the vertiports in the right way to manage those logistics, that is one of the biggest challenges that we have as we design urban air mobility. And then, of course, the source of the energy, it's a tremendously big challenge that we have to address if we want to have clean systems operating in urban air mobility. So why don't we pass it over to Mario? We have a few questions. Why don't we throw them out to the think tankers here?
Thank you, Felipe. Yeah, so here we have a first question from Kaswar Abbas. Basically, he is asking, how is surveillance, separation, visibility, control, and/or emergency support being planned? So again, surveillance, separation,
who wants to jump into that? How we're planning surveillance, separation, visibility, control? Probably Simon or Jared.
Yeah, I can jump on that. So that's what a DOT does, right? Is the infrastructure for those things. And the way we intend on monitoring the system is one, you have a UTM, an unmanned traffic management system, monitoring not only the corridors but the vehicles. Not unlike the current ATC system, where you have transponders in aircraft that tell you, here's who I am, here's where I am, here's who I am, here's where I am. The tough part about figuring that out for urban air mobility is it has to be seamless across a very, very short distance across the city. All right. Here's who I am, here's where I am. The other thing we have to survey or surveil is rogue drones. So we have a couple of functions. We have a GPS RTK, real-time kinetic system in Utah that we can track drones that are on this. Track those, it'll give us exact position, time. So Fordham Technologies, which many of you are familiar with, is actually based in Mount Pleasant, Utah. The mini radar actually allow us to digitize the airspace so that we can see everything that's moving in it, whether it's a balloon, a flock of birds, or little Bobby's down the street and he's flying his drone up 100 feet, 200 feet, 300 feet, 400 feet. Okay, we know we're going to have a problem. But we can see that and mitigate that problem before it actually becomes a problem. So those are the couple ways that we're answering or solving those problems.
Right.
If I could tap onto that, we just did a workshop kind of focused on this earlier this month. And one of the things that's coming out of this is there's a lot of people that are really thinking about these issues, starting with, the NASA folks with their grand challenge, where I guess it's the national campaign now, where they're putting a lot of focus on air traffic management. But on top of that, there's a number of people at the FAA that are very receptive to new ideas on traffic management, and they are actively putting together standards committees to put together the right solutions, or at least a framework for solutions for DOTs and the like, to go off and implement something that will make sense, be safe, or at least as safe as we can define at the moment.
Right. I just want to add to Kaswar Abba's question that in the end, we don't intend urban air mobility to connect to air traffic control, the regular and the traditional one. It's probably going to be a new type of dedicated control system, which is what we call a traffic management system, as Jared was explaining. So our next question, Mario?
Next question is from Giselle Laborde. She asks, please dive into urban planning of cities, especially because homes could be located more on the periphery of cities, suburbs, or rural areas, in response to being able to access air transportation and avoid traffic on land.
So, Luis?
Yeah, maybe I can get that one. Yeah, for sure. I think this idea is fantastic in that sense. Like probably we can provide mobility choice for people living in the suburbs, and that's going to help a lot. Probably in terms of congestion. It depends, of course, as I was saying, if people change the mentality and then they start using this as a mass transportation. So probably it's not going to happen tomorrow. As Felipe was explaining, first we will start with moving goods, and then people probably is going to be next step. In the other sense, I am in our group, we are always trying to have people living and working in a walkable distance. So I have a mixed feelings with the idea of having people living outside, in the suburbs and going to work into the center. But I like the idea that Felipe was explaining to me, like, this could be a very good mobility mode choice for people that really are living maybe even in the countryside, even a little bit farther. It's not like in the suburbs. It's like, and then it's starting to make a lot of sense. It's like a little bit is because for the suburbs you have the car that we are trying to avoid by this idea of living and working a walkable distance, but a little bit farther, lost, like more in the nature. For that kind of things, I think, because you are building, as Felipe was talking the other day with me, you are building a new infrastructure that is almost lightweight, because you don't have to build like huge highways, so you are not impacting into nature, and then you have access to places that they probably are unique. So in that sense, I can see like a very interesting grid of new infrastructure that is lightweight and is providing this opportunity to live outside of the city and work inside of the city. But for the normal transition of suburbs, I think that the humans, we need to shift a little bit. The cities, they used to be human scale during 2,000 years. So they used to be walkable and compact and dense and diverse. And now with the car 100 years ago, we destroyed that idea, and we are living in this kind of, sprawl urban tissues. But I think flying cars, flying mobility is gonna be, helping in a different way, making a new way of commuting and a new way of living outside of the city, but working in the city. It's not in the suburbs, it's literally outside.
Yeah, by all means, we definitely see urban mobility as a new type of infrastructure. It's probably going to be radically disruptive in many ways, in the sense that it does not require physical construction of rails, roads, or any other means. It's virtual infrastructure that alleviates city growth. And there's a lot of pressure for city growth in many parts of the world. And that pressure, to her question, is what's in big parts, that's what's creating the traffic problem and the problems that we see currently in our cities. So she did ask, a part of her question was around the impacts of COVID. Does anybody want to comment on that pretty quickly? If COVID's going to have any impacts on urban mobility?
Yeah, COVID and working from home. Yeah.
For sure. I mean, David, maybe you want to talk.
Just quickly, the only places where I've factored it in so far is during the basically takeoff, transport, landing, and then servicing areas. So that's part of the cycle of turning around every vehicle, and sanitization and cleansing will have to be part of that process. What I'm really hoping is that this is not such a big problem by the time we get this up.
All right. Do we have our next question, Mario?
Next question is from Andres Morfin. What do the panelists think about the e-hang approach? From what I understand, they want a monopoly. So basically, only e-hang vehicles will be allowed in a certain urban area, and e-hang will plan all the geodesics.
Well, who wants to jump into this one? I think it's a very interesting thing that Andres is bringing up, not about any company in particular, but about the fact that urban mobility calls for multiplicity, and there is not one company going to be able to provide the entire service. This is a very broad spectrum type of industry. It is a new industry. So with that, who wants to jump into this one?
I know we're close on time, but let me just say, I think we agree in the sense that, that no one company should have any monopoly over this, over any transportation service, mobility service of the future. That's just, basic. I think you'll definitely see certain service providers come out first, whether it's the OEM, the aircraft companies. They may be flying first, but there's enough opportunities and need for a whole host of providers, and it would be a mistake at the ecosystem level to design, whether it's infrastructure, vertiport, or any kind of service, to meet only the requirements and standards of one company. That's really, I think, at least from Jaunt's standpoint, we can assure you it's going to be a collaborative effort with other OEMs. Although there are competitors, they are also, we're in this together to make sure that the industry succeeds. So that's really the key point there.
Yeah, and I think Jared wanted to jump in, and I think it's very valuable because Jared is leading another ecosystem in Utah, just as we are leading an ecosystem in Latin America. And an ecosystem means a whole bunch of companies collaborating and working together towards that end, as Simon was saying. Jared?
Yeah, I absolutely agree. The airspace agnostic, right? UPS sponsor lanes; they don't get monopolies on lanes. Delta, Southwest, American Airlines, they don't buy airway. Where I see this, right? So Delta has a hub in Salt Lake, and of our 60 gates, they own 40 of them. And if another airline wants to use one of Delta's gates, they negotiate that and they pay a premium. You know, I can see a Jaunt or an eHang or a Bell coming in and building a vertiport in conjunction with the engineering and city planning, where they might say, well, we're going to put in, you know, 20 landing pads, and this is our private vertiport, and we're going to lease out space or charge a landing fee to other companies. But the airspace itself has to be agnostic, and the system itself has to be agnostic.
All right, anybody want to comment on that? Shall we go to our next question? Airio?
So the last question, again from Andres Morfin. He says, perhaps slightly off topic, do we think that there is a future with designing VTOLs that use biofuel or hydrogen fuel?
Okay, Energy Source wants to comment on that one.
I think the first answer is yes. As we've gone through this tonight, it's clear that we do not yet have a decent energy solution for this entire industry. You know, there have been a number of liquid fuel to electric companies that have been funded by DARPA over the last 3 years that have been working on that kind of an engine. The only problem with hydrogen right now is A, sourcing it, and then B, you know, it's still expensive. But you know, the lead in there is that it won't get cheap until somebody starts using it. So there are a lot of problems here, and we're all still very looking at at solutions, and I think everything's on the table.
Jim?
So, since I think I brought up the hydrogen aspect of it, I think there's lots of ways to generate hydrogen. But there's a number of issues specifically with hydrogen. First is overcoming the perception that it is very unsafe. In some respects, it is unsafe, but not any more unsafe than kerosene or gasoline from that perspective. It's just unsafe in different ways. The packaging of hydrogen for use in a vehicle, that's pretty problematic. You can't just grab hydrogen out of the air. You actually have to make it and put it in a container and utilize it. And getting a lot of hydrogen in a small amount of space is pretty difficult. But I think we can work on those issues. And then what's the form of conversion from hydrogen energy to what's being used for propulsion, right? So if you're going to just burn it as a combustible element, that's pretty straightforward in the conversion of what we're using today. But if we're going to take and use a fuel cell, that's kind of a different approach that fits in better with the all-electric drive, right? So instead of sourcing everything directly from a battery, you have a fuel cell that's supplemented with a battery that could provide a different solution. But there's lots of issues with hydrogen as well. But I think, if you look far enough into the future, we might have an opportunity to utilize it in different ways.
Yeah, I mean, just to comment on that, the energy aspect of urban mobility is very central, very important, and one of the most important aspects of urban mobility. Actually, many people even say that urban mobility is actually an energy industry. So it's a really interesting subject. As we choose the energy source, we have to, Andres, to your question, we have to address the cost of that energy source. We have to address the technologies and the infrastructure that we're going to build. As we set up an infrastructure for energy, we're not going to be able to change that very easily in the future. So choosing that energy infrastructure is central to urban air mobility. And we are collaborating with all the ecosystem participants, air vehicle developers, battery developers, and so on, to come up with the best solutions for the energy source. Of course, it's a very deep subject. We still have another question there. I think it's for Simon.
Again from Andres. For Simon, if we look at the ROSA, will noise be an issue if powered by sustainable fuels? I am asking because of the Airbus concepts that were recently released on Monday. I thought they were going to go for electric concepts.
So I think I understood that it's the ROSA is just for everyone's, I guess, benefit. The ROSA is reduced operating speed aircraft. So that's our technology where we are able to reduce the main rotor as part of our patented technology to reduce it in cruise to get the speeds up to, airplane levels. So there's no noise signature coming from that main rotor in cruise, which is obviously very different than conventional helicopters. The fuel, the sustainable fuel, so the noise that, again, depending on your propulsion system, whether if it's a fuel-based system, like a turbine or a piston engine, you're going to have some noise emanating from the vehicle, depending on what flight phase you're operating on, regardless of whether you're what fuel you're combusting. So there's a difference between all electric and hybrid from a noise standpoint. There's definitely a contribution of noise, but the design of the airframe, of the configuration of the aircraft is, in our case, what would determine the noise and acoustics, the speed of the propellers, the tip speed of the propellers, things of that nature. So there's a little bit of decoupling between the design of the aircraft and the propulsion system as from a noise standpoint.
Great. So guys, we're now a bit over time here, and we unfortunately have to come to a closing. It's city implementation and urban aspects of urban air mobility are tremendously central to our development. The aeronautics part of urban air mobility, at least from the Varon vehicles perspective, it's just a tool. It's a tool for us to achieve our mission. And our mission is an urban mission. The problems we're tackling are city problems. Our customers are urban customers. And that perspective really shapes the entire development that we're carrying out. I want to thank our panelists for being here with us in this think tank today. It's been a really interesting conversation, just barely scratching the surface of very deep and very important and relevant points in our developments as we move forward in implementing urban air mobility in Latin America. So I want to thank you guys for participating and being part of this think tank. I want to invite everybody and our attendees to join us in our next think tank. It's going to be on October the 2nd. It's going to be about insurance, how we're going to innovate around the new types of insurance that are required to allow operation of urban air mobility. So with that, I wish you a great rest of your day, and thank you very much for being here. Bye-bye.